Spherical polar coordinate system, we have the transformation equations x equals r sine theta cos phi, y equals r sine theta sin phi, and z equals r cos theta. We will prove that the Jacobian involved when you change from Cartesian system to spherical coordinate system is obtained as Jacobian equals r square sine theta. Suppose that P is the point lying in the xyz space and you project it to xy plane and you obtain a point M whose distance from origin is r, and this radial vector r is at angle phi from x-axis, phi being measured in anti-clockwise direction or positive direction from x-axis. Now consider point P back again, which is also at the same distance r from the origin, and this radial vector r is at an angle theta measured in positive direction from z-axis, or we have angle between z-axis and OP equals theta, and these three variables constitute spherical coordinate system r, theta and phi. Notice that in cylindrical coordinate system, once you project you get angle and radial vector. When this radial vector moves from 0 to 2 pi in the xy plane, you will get a circle. When this circle moves along z-axis, this movement determines the height of the cylinder. This radial line, when rotates from 0 to 2 pi, circle is obtained, and circle which moves in this vertical direction along the z-axis, whose range of variation determines the height of the cylinder. But in case of spherical coordinate system, this radial vector OM has to again undergo angular variation to form upper hemisphere or lower hemisphere or full sphere. Just as in cylindrical coordinate system, in the xy plane, we will get a circle, but this circle in the xy plane rotates, and the angle of rotation determines part of sphere formed in xyz space. To determine Jacobian, we will have to evaluate first order partial derivatives of x, y and z with respect to independent variables r, theta and phi. We have dou x by dou r equals sine theta cos phi, dou x by dou theta equals r cos theta cos phi, dou x by dou phi equals negative r sin theta sin phi. Similarly, dou y by dou r equals sin theta sin phi, dou y by dou theta equals r cos theta sin phi, dou y by dou phi equals r sin theta cos phi, dou z by dou r equals cos theta, dou z by dou theta equals negative r sin theta, and dou z by dou phi equals 0. Thus we have the Jacobian obtained like this, and expanding along the first row we will get Jacobian equals r square sin theta.